Hello, everyone. I welcome you all to this live session by Scalar Academy. And in today's session, we'll be performing some very simple exploratory data analysis projects using our favorite language, which is Python. Now, before I start off, just give me a quick confirmation if you can hear me properly and see me properly. Let me also verify it from my side as well. Let me check if everything is proper.
If you can hear me properly.
So I see that the sound is proper, the video is also proper, and also if you guys can give me a quick confirmation, you can just give me a quick thumbs up or just write down yes in the chat window, whatever works. So there are six people right now. Can I get a thumbs up from everyone or yes from everyone? And also, I want this session to be quite interactive. So if you have any questions, any suggestions, please put them up in the chat window and we shall definitely take them up. Now, also before I start off, I'd request you guys to also subscribe to our channel if you haven't yet subscribed to, because that would encourage us to keep putting up high quality content, high quality technical videos on a regular basis. And also, we'll be doing these live sessions on a regular basis as well. And also, please do like this video. This will help the YouTube algorithm to bring in more people onto this video. Great. So on that note, let me go ahead and share my screen over here. So folks, I've opened up Jupyter Notebook and this is just an ID which we'll be using to perform all of our tasks today. And let me guide you through what we'll be doing. So we'll start off by working with some of the basic libraries in Python, which would be Pandas and Seaborn. So Pandas is a library which is used for data manipulation. Seaborn is a library which is used for data visualization. And then we'll go ahead and perform certain exploratory data analysis tasks on top of the COVID dataset and also on top of the IPL dataset. So this is going to be really interesting. Now, if you have again any questions, if you haven't worked with Python before or any of the languages before, you can just put up your queries in the chat window. I'll parallelly take them up. Now, these two libraries which we'll be covering are really important. So I hope that your basics are properly covered. So the first and most important library for any of your data analysis tasks or data science tasks would be your Pandas library. And Pandas stands for panel data. Now, with the help of this particular library, you can go ahead and create single dimensional data structures as well as two dimensional data structures. And we'll be mostly focusing on the two dimensional data structures, which are known as data frames. Now, to give you a simple analogy, let's say if you have worked with an Excel sheet before, or if you work with SQL before, you'll have something in a tabular format, isn't it? And you're storing data in that tabular format. So, Pandas provides you something on a similar lines, and that is known as a data frame. And this data frame has rows and columns, and you store your data over there. Now, my task would be import pandas. So this is a library and I'd have to import it. So I'll write down import pandas as PD. Now, PD is just an alias to import this library. Again, most of the coders are lazy. So every time if I do want to invoke some functions inside this library or maybe use some subroutines inside this library, I instead of writing pandas every time, what I can do is I can just write down PD because we are just lazy and we just need a shortcut for that. So I can use PD whenever I want. So now that I have imported this, let's go ahead and create the data frame. Now to create a data frame, you shall write down pd.data frame, and here you'd have to keep in mind that D and F are capital. Now if you give either of these are small or both of them as small, then this particular method will not work. I've written down pd.data frame, and what I want to do is, let's just say I want to create a simple marks data frame over here. And for this, I am creating a dictionary. And inside this dictionary, I'll have the key over here. Let me just have the key as, I'll call this as student name, and I'll have a list of values. So let's say the first student is Alex. The second student is, let's call him Ram. The third student is, let's say, Chan. So we have three students over here, or names of three students over here. Going ahead, I'd also want marks of these students. So I'll have the next key, and the next key I will give it as student marks. And for this, I would want to give in a list of values as well. So here, let's say Alex has scored around 45 marks, Ram has scored 67 marks, and then we have Chan who has scored 78 marks. Now that this is set, all I have to do is go ahead and execute this. And what this gives us is a data frame. So this, what you see, is our simple two-dimensional tabular structure. So here, the keys which we gave, student name and student marks, those we have as the column names over here. And as you see, Alex, Ram, and Chan, these are basically your values. And these values, you have them stored as records. Similarly, you have these marks over here. These marks are also stored as records. So if you'd want to create a data frame from a dictionary, what you're doing is the keys become your column names and the values become your records. Now, if I'd want to give in a name for this data frame as well, let me go ahead and call this as student data. I'll execute this. And this time, when I print out student data, you will see that I've successfully created this data frame. And this, folks, is the basic essence of a Pandas data frame. Hopefully, you're following till here. Let me just go ahead and see some more questions over here. Avijit is asking, good evening, is Python better than R when it comes to data science? That's a really good question, Avijit. So the answer is very simple. Both of them have their own applications. Now, when you only talk about R, so R, very simply put, it's a language which was developed by statisticians for statisticians. So if you'd want to do any sort of statistical analysis or exploratory data analysis or maybe even visualization, then R should be a go-to language. But on the other hand, if you'd want to do heavy machine learning stuff or deep learning stuff, then Python needs to be a go-to language. And also a major distinguishing factor over here would be most of the people in academia or most of the people who are stats grads or mathematics grads who would prefer R over Python, and most people in the industry would prefer Python over R. So both of them have their own applications, and it would totally depend on what is it that you'd want to do. So hopefully that answers your question. Priya is asking, is Seaborn better than Matplotlib? So that's a very interesting question, Priya. The simple answer is yes, because Seaborn is a library which is built on top of Matplotlib. So you can consider that Matplotlib is version 0 and Seaborn is version 1. So the visualization which you create with Seaborn will obviously be better than Matplotlib. So you guys can keep putting up your questions over here. I'll take them up parallelly. And also, folks who have joined in new, if you haven't yet liked the video, click the like button. And also, if you haven't yet subscribed to our channel, click the subscribe button. Great. So now that we've had a basic introduction to this, let's also see how can we load a CSV file. So what we've done over here is we've created a data frame, isn't it? But we would also have a lot of CSV files. CSV files are essentially your tabular data. And if we want to directly load those CSV files, that is also something which we can do. So here, I'll write down pd.read underscore CSV. Very simple function over here. And let me open up the home page over here. And here you will see, let me just use Command F and let me write down .csv. You will see that I have a lot of CSV files over here. Now, out of this, there's a CSV file called as iris.csv. Let me just go ahead and open that up or store it in a new object, and I'll call that object as iris. So using this read underscore CSV, I've loaded this file and I've stored it in a new object. Now you'll have to remember that I can give it any name. I've given it the name of iris because that is the name of the file. Now, if I want to have a glance at the first 5 records of any data frame, I have a method called as head. So when I write down iris.head, I will get the first 5 records of this data frame. Now, what is this iris file? Iris file represents a species of a flower or 3 different species of a flower called as iris. So you have a flower iris, and that iris flower has three different species, which would be Setusa, versicolor, and virginica. And for these three different species, you have the different attributes over here. And these different attributes would be sepal length, sepal width, petal length, and petal width. Now, if I want to do simple analysis on top of this, let me just go ahead and what I'll do is I'll cut all of this out so that this is much more clearer to you. I have this head method right in front of me. Now, let's say from this head method or from this iris data frame, if I want to extract only those records where the sepal length value is greater than 5. So right now, if you look at these 5 records, you will see that I have some values where the value is less than 5, isn't it? But if I want to extract all the records from this iris data frame where the sepal length value is greater than 5, let's see how can we do that. I'll write down iris. Inside this or inside the parenthesis, I need to give in the condition. So what is the condition? Sepal underscore length should be greater than 5. Now, when I enter, you will see that I have a bunch of true and false values. So what does this exactly mean? And now you get a true value wherever this condition is satisfied. So here for index 0, you have true because 5.1 is greater than 5. Next, you have 4 false because 1, 2, 3, and 4. 4.9 is less than 5. 4.7 is less than 5. 4.6 is less than 5. 5, it's not greater than 5. And it's also not, it's not greater than 5. And since it's not greater than 5, this is also evaluated to false. So basically, this condition will give you only trues wherever it is satisfied. Now, what I'd want to do is I'd want to select this entire thing over here. I'll cut this out and I will paste this in the iris data frame, which would give me only those records where this condition is satisfied. Now, if I go ahead and hit enter, here you shall see, if you look at the sepal length column, you shall see that all of the values which are present in this column, the value is greater than 5. So this is how we can do simple extracting from whatever data frame we have. Now, if I want to store it in a new object and give it a new name, let's say I don't want to store it as iris SL5. Let me hit enter. And now when I open this iris SL5, you will see that this is my new object over here and this has all of the values. Now analogous to the head method, I also have something called as the tail method. Again, let me just go ahead and erase all of the stuff from this. I'll write down iris dot tail. So as the head method gave us the first 5 records in a data frame, similarly, the tail method would give us the last 5 records in a data frame, right? So that is pretty much the only difference. And also by default, the head or the tail method will give you only 5 records. Now, instead of 5 records, let's say if I want the last 3 records, let me just write down 3 over here. And when I hit enter, you will see that I've got the last 3 records from this. Similarly, if I want the last 10 records, I'll put in 10. And when I hit enter, you will see that I've got the last 10 records from this. So simple stuff. This is how we can work with the head method and the tail method. Let me again have a glance at the head method over here. Let me change this to head and I'll only keep the 5 records over here. Now, from this, if I want to know what is the type of this, I can just use type. Inside this, I'll pass an iris. You will see that this is pandas.core.frame.frame data frame, which would mean that this is a data frame type. So now again, from this entire iris data frame, if I'd want to extract only 2 columns, so if I'd want to extract only the sepal length column and the petal length column, now for that, what I'll do is I'll give in the name of the data frame, I'll give in 2 parentheses, and I'll only give in the names of the columns which I would want to extract. So I'd want sepal length, and I would also want petal length over here. So I've extracted sepal length, I've extracted petal length, and I will store this in, again, let's say iris length attributes. I'll execute this. Now when I run this, you shall see that from this original data frame, which was this entire thing, I've extracted only two columns over here, which are the sepal length and the petal length. So hopefully this is clear till now. Let me head back to chat and see if there are any more questions. Arjun is asking what is the difference between series and data frame. The answer is very simple. Series is a single dimensional data structure where you have data only arranged in a column. And when it comes to a data frame, you have rows and columns. So it's a two-dimensional data structure. Rakesh is asking how long is the session? So this will be for 1 hour and probably this will end around 6 o'clock. So folks, if you have any more questions, put them up in the chat. I will be taking them up. So this is everything or the basic fundamentals of the Pandas library. Now we'll go ahead and work with the visualization library, which is Seaborn. Now, as I said, Seaborn is built on top of matplotlib. So first, let me go ahead and import matplotlib. So for that, I'll have from matplotlib import pyplot as plt. And after this, I'll also import Seaborn. So I'll have import Seaborn as SNS. So these are the two libraries which I've imported. And now let's make a very simple line plot. And for that line plot, I'd actually, so SNS or the Seaborn library would also have certain built-in data sets. So that's a data set called as fMRI. So SNS dot data load data set. I'll give them the name of the data set, which is fMRI. Let me go ahead and store it in another object called as fMRI. And let me have a glance at this fMRI dot head. What I've done over here is there's an inbuilt dataset called as fMRI in the Seaborn library. I've imported this. Now this has all of these different columns over here: subject, time point, event, region, and signal. Now, I'd want to make a line plot. And for this line plot, what I'll do is I'll probably have the time point at the bottom and the signal at the top or on the y-axis. So time point will be on the x-axis, signal would be on the y-axis. So to make the line plot, I'll also add a comment over here. Let me put in as line plot. Here I'll write down SNS dot line plot. Now, I want to give something onto the x-axis and something onto the y-axis. So here I'll have x is equal to, I'll have time point, and onto the y-axis, I'll pass in signal. Then going ahead, both of these columns are coming from a data set called as fMRI or from a data frame called as fMRI, and this is what we get. Now, after this, if I do not want this metadata, I'll just have plt.show. And this is our result. Hopefully, all of you can see this properly. So on the x-axis, what you can see is the time point, and that starts from 0, goes on till 17.5. So let's say this is the time unit or the time metric is seconds. So this starts at zero point 0.0 seconds, goes on till 17.5 seconds, and you have the value of the signal over here. So this starts at 0, has its peak at 0.15, then it goes beneath 0, and then it sort of stabilizes or stagnates at the value 0 again. So this is sort of interesting, isn't it? And now, if you look at this properly, if you look at this data, we have something called as an event, and there would be two different events over here. And if I'd want to have a glance, or if I'd want to make a line plot for both of these different events in the same graph, that is something which I can do. So here I have an attribute called as hue, and onto the hue attribute, I'll be mapping the event column. And now when I run this, you will see that I'll have two lines. So here the blue colored line represents the stem event. The orange or the crimson color line represents your queue event. So this is how we are creating a simple line plot. So folks, again, if you have any questions, put them up in the chat. Right, so this is how you can create a line plot. Now let's also see how can we create a scatter plot. Again, let me delete this entire thing over here. Let me also remove this. And for the scatter plot, we'll be using the iris data frame. So now let me write down pd dot read underscore csv. I'll have iris.csv. Again, let me go ahead and store it in iris over here. I'll hit enter. Let me have a glance at the first file record. So I'll have iris.head. So now that I have this, I'd want to make a scatter plot between the sepal length column and the petal length column. So I'd want to understand if the sepal length varies, how does the petal length vary according to it? For this, I'll write down SNS dot scatter plot. Onto the x-axis, I'll be mapping sepal length. Onto the y-axis, I'll be mapping petal length. And then probably since both of these columns are coming from the iris data frame, I'll set data is equal to iris, and I'll write down plt dot show over here, and this is what you get. Let me also add in a title over here. So I'll have plt dot title, and the title I'll set as sepal length versus petal length. And now when I run this, you have the title sepal length versus petal length. On the x-axis, you have sepal length. On the y-axis, you have petal length. Well, this is interesting, isn't it? So this seems like there's a linear relationship between the sepal length and the petal length, which would mean that as the value of sepal length increases, the value of the petal length also increases. Now here, when earlier we loaded the iris data frame, I had mentioned that this iris flower has three species, which would be Setosa, versicolor, and virginica. And if I'd want to distinguish those three species using different colors, that is something which I can also do. So here what I'll do is I'll use the hue attribute again, and onto the hue attribute, I will be mapping the species column. And now when I run this, you will see that I have dots of three different colors. And if you look at the legend over here, you will see that the blue color dots represent your Setosa species, orange color dot represent your versicolor species, your green color dots represent your virginica species. Now, if we want to draw some inferences, it would seem that the Setosa species would have the lowest value of sepal length and petal length, and your virginica species would have the highest values of sepal length and petal length, and versicolor somewhere lies in the middle. So hopefully this is clear till here. So we've looked at the basics of pandas, we've looked at the basics of Seaborn as well. Now what I'd want to do is I'd want to sort of do a mini exploratory data analysis or a mini project on top of the COVID data set. And we'll be using both the pandas data frames as well as the Seaborn data frames for this. So let's start off with this. So I'll write down import pandas as PD. Then I'll import matplotlib and Seaborn, both of them. I'll have from matplotlib import pyplot as plt. Then I'll write down import Seaborn as SNS. So these are the three libraries which I'm importing, and these are the only three libraries which I'll be needing for this project. Now I need to load the data set. So I'll have pd.read underscore csv. I have a file called as covidindia.csv. So I'll have covidindia.csv. Let me store this in an object called as covid. Let me show it to you guys. So I'll have covid.head, and you shall see that these are all of the different records which are present. So we have S number, which is essentially the row number. That's pretty much it. You have the date. Now, this is the date on which the number of confirmed cases were recorded, or the cured cases were recorded, or the number of deaths were recorded. So it would seem that on this seems to be 30th of Jan or 2020. So on 30th of Jan 2020 in Kerala, there was one confirmed case. On 31st Jan, there was again one confirmed case. On 3rd February, it seems that there were three confirmed cases in Kerala. Now, this is whether this person was an Indian national or a foreign national. And you have the number of cured cases, the number of deaths, and so on. This just tells you from which state or which union territory was this person from. So, hopefully, this is clear about the data set. Arjun has some state as well. Sure, we'll definitely do that. Probably we'll cover 2 to 3 states, right? So, folks, just give me a quick yes if you understand what this data set is about. What are we going to do on this? Right. Also, if you have any more recommendations, let's say if you're from Bihar and you'd want me to analyze the Bihar state, I'll do that, right? Or let's say if you're from maybe Andhra Pradesh, if you want me to analyze how is the COVID situation in Andhra Pradesh, let's also do that. Okay. So now that we've looked at the head, what I'd want to do is I'd want to clean this up a bit. Now, out of all of this, I wouldn't require some of the columns. I wouldn't require S number. I wouldn't require the time. I wouldn't require whether this person is Indian national or foreign national because I have this final column over here, which just tells me the total number of confirmed candidates. So what I'll do is I'll write down COVID, and from this I'll only select the columns which I need. So I'd want the date column. I'd want state slash union territory column. Then I'll have the cured column. Going ahead, I'll have the deaths column, and then I'll also have the confirmed column. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of the 9 columns, I'm selecting only the 5 columns because these are the ones which are important to us. I'll select this entire thing and I will store this back into COVID. Let me run this. Now, when I have COVID dot head, you will see that from this entire data frame, I've extracted only these. Now, let me make it even more simpler. What I'd want is, so you'll see that this seems to be a really long name. Now, instead of state slash union territory, I just want the name of the column as state. Similarly, all of these are in capital letters. Let me just go ahead and convert the column names into small letters because that's more easier for me when I'm analyzing. So again, let me just go ahead and cut these out from here so that we have more space. So this is our head. From this, what I'd want is I'd want to rename some of the columns or all of the columns. I'd write down COVID dot rename. I have an attribute called as columns, and I'll use a dictionary to change the original names. Let's say the actual name is date, and here what I want to do is I just want to change this D from capital to small. Similarly, next up I have state slash union territory. So state slash union territory, and this I'd only want to keep it as state. So the key, inside the key you'll given the original name. For the value you will given the name to which you'd want it to be changed. Now let me actually run this and show you the results. So if you look at this, this is the original data frame. If you look at this particular result, you will see that date has been changed like this, where D is small. Again, state slash union territory has been changed like this. Let me store it back into COVID over here, and I'll run this. Now, when I show you guys COVID.head, this is what I have. Again, I have cured, deaths, and confirmed. In here as well, I have the first letters to be capital. I want to make them to be small. So I'll write down COVID.rename, and here I'll use the attribute columns. Again, I'll give in a dictionary over here. What I'll do is I want to change the name of the column cured. I'll give in this. I'll write down cured. Then I have deaths. Probably I'll just make it even more simple. I'll just keep it as death. Then I have confirmed, and I'll keep it as confirm, just confirm over here. And again, I'll go ahead and store it back into COVID. Now that this is done, let me again delete this entire thing from this, and I'll do COVID.head. And when I perform COVID.head, this is what I have, right? So initially we started off the really huge data frame where we had 9 columns. Now we have truncated it into this very simple, nice looking data frame which we have. Let me go back to the chat and see if there are any more questions. So Pooja is asking, can you give a real life example of a data frame? So Pooja, right now what you're seeing is a real life example of a data frame. So this data frame has been, so this is an open source data set available on Kaggle, and you will find numerous such data sets on Kaggle or many other platforms, right? So this probably some agency would have collated the data, probably some agency in India itself, or probably they did a survey and they understood on a day-to-day basis what was the what was the change. So on 30th January, how many confirmed cases were there? On 2nd February, how many confirmed cases were there? On 3rd February, how many confirmed cases were there? Right? So there's day-to-day analysis. Whatever was being recorded was turned into a CSV file, and this CSV file we've converted into a data frame. Now, most of your real life data frames would pretty much look the same, but this is also structured data. Now, you will also have a lot of data sets which are not really structured, right? Because when you're collecting data, there could be a lot of unnecessary information, there could be a lot of noise. So, as a data scientist, you would have to declutter the noise as well. So, that would also be your task when you're working on the pre processing of your data set. Rakesh is asking, is it mandatory to import matplotlib to use Seaborn? So let's just actually verify that. What I'll do is, let me open up a new notebook over here and let's see if we can run Seaborn, import Seaborn as SNS. Now let's see if we can use Seaborn without importing matplotlib. So I'll just have SNS dot load data set. I'll have fMRI, and this I'll go ahead and store it in fMRI. So you have loaded it. So it seems like Seaborn does work without using your matplotlib. So hopefully that answers your question, Rakesh. So let me actually cancel this. Let me go back to over here. So what we've done over here is we have just created a smaller version or a sub data frame of our original data frame. Now that we have this, what I do want to do is probably explore different states or analyze, how is the growth of the confirmed cases in different states. Let's start with Kerala because that is what we see over here. What I want to do is I'd want to extract only this. So I'll write down COVID, and here I need to extract all those records where the state is equal to Kerala. So I'll write down Kerala over here. Now, when I run this, again, you will see that I have a bunch of true and false values. I have a true value wherever this condition is satisfied. I have a false value wherever this condition is not satisfied. Now that this is there, what I'd want to do is I'd want to extract all the records where this condition is true. I'll cut this out and I'll paste it inside this parenthesis, and I shall store this in a new object called as Kerala. I've done this. Let me open up Kerala over here. I'll have Kerala.head, and as you see, now let me actually remove head probably because let me actually print this entire thing. So if you look at this, if you look at the state column, you will see that all of the values are Kerala. Now, that is because from this entire data frame, we have extracted only those records or only the records pertaining to the Kerala state. And if you look at the first row as well as the last row, you will see that on or as of 30th January 2020, there was only one confirmed case. If you look at the bottom one over here, so the bottom one is 24th of June 2021. So as of 24th June, let me actually count this. So this is probably you'll have around 28 lakh cases. You have 28 lakh cases, 42,247. So you see, in a span of 1.5 year, Kerala has had 28 lakh cases. So that's pretty interesting, isn't it? And if I actually want to make a graph for the growth of this, I can go ahead and do that. So for this, let me use SNS, which is Seaborn. So SNS, as you see over here, is just the alias or the short form for the Seaborn library. Now, again, let me cut this entire thing out from here. So again, before this, let me add a new cell. I'll actually have a cell below this, insert cell below. Let me cut this out over here. I'll write down Kerala dot head. Kerala is not defined. I'll have it as capital. Now let me run this, and this is what we have. Now from this, I'd want to make a line plot. Since I want to make a line plot, I'll have SNS dot line plot, and I'd have to map something on the x-axis, something on the y-axis. So on the x-axis, I'll map the date. On the y-axis, I'll map the confirmed column, which basically means the number of confirmed cases. On x, I will have x is equal to date, and on y, I shall have confirm. Then both of these columns are obviously coming from the data frame Kerala. Now, at the bottom, I'll just have plt.show. Let's wait for probably a couple of seconds for the result. Right, so this, if you look at this, right, so this probably around for the first 3 4 months, or maybe even the 6 odd months, the growth wasn't really exponential, right? And this probably would have been the would have been around the end of 2020. That is when these cases started to increase exponentially. Again, over here, this probably would be the second wave, where again this is almost like you have a straight line, where again cases are increasing exponentially over here. Right, so this is sort of interesting over here. This helps you to analyze how is the growth of cases in a particular state. Now, if I want to do some fancy stuff, let's say if just I want to change the color of this particular line, I'll have an attribute called as color, and for this I'll give an R. Now when I run this, again, let's just wait for a couple of seconds. So here you shall see that the blue colored line has been turned into red. Right. So this is how we were able to analyze what was happening with respect to the Kerala state. So someone had asked me to analyze Assam state as well. Let's go ahead and do that. Let me remove this one over here. Let's cut it out. Let's keep the Kerala graph over here for reference. Let me reduce the zoom over here. Now what I'd want to do is I'd want to extract all of the records where the state is equal to a sum. I'll increase the size of this. COVID state is double equal to a sum. Now, when I run this, you have a bunch of false values. So in these indices, basically, you don't really have a record for the Assam state. And now I'd want to extract this entire thing, and I'll have it over here. I'll store the result in a new object. I'll call that object as a sum. Now I would just want to have a glance at the head of this. So I'll have a sum dot head. And now when you have a glance at this, you will see that in the second column, which is the state column, all of the values are equal to a sum, right? So that's pretty simple over there. Again, let me just head to the chat and see if there are any more questions. Exxon is asking, do you have a full course video on Python? So Exxon, yes, we actually have 2 to 3 full courses on Python. So you can just go to our YouTube channel, explore it. You'll find a couple of full courses on Python. So you'll have one full course which would help you to use Python and Django to create website. Then you have a full course with Python plus interview questions, and that will also help you to learn Python from the data science side of things. So now that we've done this, what I'd want to do is, again, I'd want to make a similar graph for the state of Assam as well. I'll copy this code, I'll paste it over here, and instead of Kerala, all I have to do is I'd have to change the name of the dataset to Assam. Let's give this a green color over here. And now when I run this, let's see how does the graph look like. So here, again, you sort of have a similar sort of thing over here, right? So initially there, I mean, the cases aren't increasing. Then you sort of have an exponential increase. Then it stagnates. After stagnation, this probably is your second wave, where again there is an exponential increase in Assam. So this is pure analysis of two particular states. Now, what I'd want to do is I'd want to understand which were the top five states where the cases were badly affected, or basically the top five states with most number of cases until 6 Jan 2021, because that is the last date which we have. So let me again cut this entire thing over here. Let me remove the stuff from here. I'll add in a new cell below this. Let me insert a cell below. Now that this is clear, I'll have COVID dot head. So this is what I have. Let me also, what I want is, so basically maximum five states with the maximum cases. So I'll write down COVID dot, I have something called as sort values, and I would want to sort this data frame with respect to a particular column. For this, I have an attribute called as by. I'll be sorting this data frame with respect to the, I'd want to sort this with respect to the confirmed column, or maybe I'd want to sort this with respect to the state column. I'll keep it with respect to state. Then I will set ascending is equal to false, because I'd want the state with the most number of cases at the top and the state with the least number of cases at the bottom. Now, when I run this, this is what I have. So I have, or before this, what I'd actually do is, let me actually extract all those records where the date is the last date. Let me again cut this out from this. Before this, there would be an intermediary step. So instead of COVID dot head, let me show you COVID dot tail. And when you look at COVID dot tail, you would see that for this particular data frame. So in this data frame, the last date for this, for which all of this information was collected, was 24th June 2021. What I'd want to do is I'd want to extract this information for all of the states. So I'll write down COVID, and this time the condition will be with respect to the date column. I'll set the date as 202106 after 06 it would be 24. So this is the date, and this is what the condition needs to be. Now, before this, again, I'll write COVID. I'll put in the parenthesis. I'll cut this. Let me write this properly over here. Right. I'll cut this from here, and I shall paste it inside the parenthesis. Now, when I run this, and if you look at this date, you shall see that the date is equal to 24th June 2021. So if you scroll down the entire thing, you will see that all of the dates are equal to 24th June 2021. And you have the information about the number of cured cases, the number of death cases, the number of confirmed cases with respect to all of the different states over here. Now, from this, I would, or before that, I will go ahead and store this in something called as, let's say, last date. Now, let me print out last date dot head. So when I print out last date dot head, this is what I have. Now, I'd want to sort this with respect to the states. So if I'd want to sort this with respect to states, or probably I'll sort this with respect to the confirmed cases, not the states. So I'll have the state with maximum number of confirmed cases at the top, the state with least number of confirmed cases at the bottom. So for that, I'll have last date dot sort values, and I am sorting this with respect to confirm, and I shall set ascending is equal to false. Now, when I run this, here you shall see that the state with the most number of confirmed cases, or the state with most number of cases as of 24th June 2021 was Maharashtra. So you see that as of 24th June 2021, there were 59 lakh 97,000 cases. Then in Kerala, you had 28 lakh 42,000. So you see this huge difference between the number of confirmed cases between the first state and the second state. This is almost double, right? Or like double the number of cases you have in Maharashtra. Then you have Karnataka closely following behind at the third spot. You have 28 lakhs confirmed cases as of 24 June. Then you have 24 lakh confirmed cases as of 24 June. Then in Andhra Pradesh, you have 18 lakh confirmed cases as of 24th June. Now, isn't this amazing, folks, right? All of this analysis we are able to do with this simple Python language. All I'm doing is running these simple commands, and with the help of these simple commands, I'm able to obtain information or dig in information from the raw data. And this is the essence of data science. So, data science is nothing but where you have this huge amount of raw data, and from that raw data, you either find patterns or you find some useful information. So when this blank Excel sheet was given to me, from that blank Excel sheet, we are able to find out all of this information, right? So we've taken this and we found out that as of 24 June, the most number of cases were in Maharashtra, and the value of that is 59 lakhs 97,587. Now, let's say if I want to show this to a client and I do want to show the top five states with maximum number of confirmed cases, I'd have to make a bar plot for that. So let's go ahead and make a bar plot. And now here again, I'll have head, and this I'll go ahead and store. And since we have only five states over here, I'll store this in something called as state phi top. Let me run this. Now, when I again print out state phi top, this is what we have. Now, from this, I'd want to make a bar plot. Now, if I'd want to make a bar plot, I would need to use Seaborn. So here I'll have SNS dot bar plot, and on the x-axis, I need to map something. So on the x-axis, I will map the state column. On the y-axis, I will map in the confirm column, and both of these columns are coming from state phi top. And let me execute this. This is what we have. So you see this beautiful plot over here. Let me add plt dot show over here as well. Let me also give in a title for this. I'll have plt dot title. I'll write down top five states with maximum number of COVID cases. And when I run this, you shall see that I've written this title, or I've added this title at the top. At the bottom, probably I'll have something called as plt dot x label, and in the x label, I'll set this as names of states, and I'll also have plt dot y label. Here I'll write down number of confirmed cases, just making it more descriptive. And as you see, here on the x-axis, the label becomes names of states. On the y-axis, the label becomes number of confirmed cases, and the title, you have it as top five states with maximum number of COVID cases. Again, if I want to increase the size of this graph, what I can do is I'll have something called as plt dot figure, and inside this I can adjust the figure size. So I'll set the figure size is equal to 10 comma 10, and let's see if there is any sort of change. And right now you see this beautiful graph in front of you. So with the help of plt.figure, we have been able to adjust the size. So on the bottom you have the states, and this basically gives you the top five states with maximum number of cases. Interesting analysis, isn't it? Karthik says data structures and algorithms, please. Yes, Karthik. We are actually uploading a lot of videos on data structures, algorithms. So I believe just yesterday we had uploaded one video on recursion. So if you haven't checked it, please check it out. And we shall be uploading a lot of videos soon. So if you have any more requests, put them up, and we'll do it. Heldific team says C++. Yes, we are working on a C++ video as well, and that is also something which we'll upload. Karthik is asking, do I need to know all about the built-in functions of Python to ace most of the interviews? The answer is no, Karthik. So in the interviews, what you'll be grilled on is how are you going to analyze it, not really on the inbuilt functions, because this is something which you can just Google it, right? And also when you're working in a real industry, all of this, you can just get it from Stack Overflow or Google, and you can just pick it up at any point of time. What matters is if your fundamentals are strong. And when I say fundamentals, so again, most people think that you can become a data scientist without proper math skills or statistic skills. So that is something which you'd have to properly work on. And after that, so again, people think that you wouldn't need the DS algo stuff when when you'd want to become a data scientist. That is sort of incorrect because let's say if you'd right now what we are doing is we are just invoking the functions or libraries which are already there, but there would come a scenario where you'd have to create your own library from scratch or create your own method from scratch. And these methods or libraries should be time efficient and space efficient. And that is when your knowledge of data structures and algorithms will also come in really handy. Great. So, folks, I guess this would be it for today's session. We've covered enough stuff. We've understood about. We started off with Pandas, then we had a bit of visualization with Seaborn, then we opened up this COVID India data set and performed a proper analysis on top of this data set. And if you have any more suggestions, you can put them up in the comment section. Once this video is done, we'll go through it and we'll definitely address them. So again, if you haven't yet subscribed, please hit the subscribe button. And if you haven't liked the video, please like the video. So thank you very much, guys, and we'll meet in the next one.